Why do compaction and erosion damage ancient fossils? Imagine finding a tiny bone or a fragment of ancient shell and wondering how it got so battered over time. The answer lies in natural processes that happen long after an organism dies. When animals or humans leave remains behind, they don't stay untouched forever. Over thousands or even millions of years, the environment works on them in ways that can make studying these fossils tricky. Two main processes that cause damage are compaction and erosion. Understanding how these work helps scientists piece together the story of human evolution and ancient life. Compaction happens when layers of sediment settle on top of a fossil. Think of stacking a bunch of heavy books on a fragile object. The weight pushes down, squeezing and pressing the fossil. This pressure can crush delicate bones or shells, deforming their shape. Over time, the minerals in the sediment can seep into the fossil, changing its chemical makeup. This process, called diagenesis, can make fossils harder to analyze because they lose their original features. For example, a small skull fragment might become flattened or cracked, making it difficult to tell what species it belonged to. Erosion is like nature's way of wearing things away. Wind, water, and ice slowly remove or break apart rocks and sediments. When erosion exposes fossils on the surface, it can cause damage. The fossils might get scratched, chipped, or weathered by the elements. Sometimes, erosion even causes fossils to break into pieces or wash away completely. This can lead to losing important clues about the environment or the species that lived there. For instance, a hominin footprint might be partially eroded, making it harder to interpret how ancient humans moved or interacted with their surroundings. Both compaction and erosion are key factors in taphonomy, the study of how organisms decay and become fossils. Compaction can sometimes protect fossils if a hard layer like limestone forms around them, acting as a shield. But if no such layer exists, fossils are more vulnerable to damage. Erosion can also help find fossils by exposing them on the surface, but that exposure often comes with the risk of damage. When fossils are uncovered through erosion, they might be fragile or incomplete, which complicates efforts to understand the past. Human activity can also influence these natural processes. Farming, construction, and land use can disturb soils, speeding up erosion and causing more damage to fossils. Sometimes, humans unintentionally destroy or scatter fossils while digging or farming. This makes it even more important for scientists to carefully study and protect fossils when they are found. In the end, compaction damages fossils by squeezing and deforming them under layers of sediment. Erosion damages fossils by wearing them away or breaking them apart once they are exposed. Both processes make it harder to keep these ancient remains intact and to interpret what they tell us about human evolution and ancient life. That's why understanding these natural forces is so important for anyone studying fossils and our shared past.